I'm here to talk to you today about our digital transformation within IT at Microsoft, specifically around networking. So just for myself, who here is a network engineer or performs network engineering duties as part of their job? Awesome, awesome. All right. So maybe let's get started and let's talk about what is network engineering. For those of you that have no clue what networking is. So network engineering is the profession where network engineers build networks. So in order for us today to go to Facebook, to go to YouTube, to watch cat videos online, we have network engineers that build complex networks that actually get us from there. So an example of this, wireless engineering, VPN engineering, load balancing, etc. That's the type of network engineering we're talking about today. So I'm here to talk to you about network development, not network engineering. So what's the main difference? The main difference between a network engineer and a network developer is the skills and tools that they use to accomplish the job, and also the thought around how you're solving the problem. So if anyone's familiar with Agile principles, this is kind of a play on Agile principles. With network development, we have four main things that we want to worry about. So instead of configuring by hand, we automate. That's a very common theme in the industry. Take what you're doing, automate it, make it simple. The second thing is, instead of manually responding to events, we go ahead and we build automation that responds to these events. Instead of being reactive, we attempt to be proactive and collect facts and make decisions on the spot in order to provide better automation. And then finally, instead of configuring devices, we go ahead and we enforce a desired state configuration. This is something that currently in the network industry there isn't a solution for, and it's something that we're working on in order to make us better, to be able to deliver features faster and to deliver at scale. So, those four pillars that we talked about, summarized: automation, event response and self-healing, fact collection, and desired state. This will be the common thing that we talk about today. So, why do we need network development? Why am I even here talking about this, right? The network is fine. There's no problems with the network. Let's kind of, put it under the rug and not think about it. Well, actually, networks are growing. Networks are growing around you. There's more network devices. With the introduction of IoT, users are bringing more devices. They want more connectivity. They want faster connectivity. There's also, I heard, this thing called the cloud. And it's not like the clouds above us. It's big. I think this conference talks about clouds just a little bit. But your users are moving to the cloud. They're packing up their apps, they're putting them in the cloud. So the one piece about your users putting their apps in the cloud, I don't think we can put a user in the cloud just yet, but your users are still sitting in the same place. They want to be able to get to the cloud just as if it was on-premise before. They want the same type of connectivity. They want a great experience. They don't want to wait for pages to load. They don't want to wait an extra 15 seconds for their cat videos to load. They want to get there now. And then in order to achieve that, the configuration for those network devices is getting more and more complex. So let's talk about our journey towards network development. We started off with automation. Automation is the low-hanging fruit that everyone can go attack today. It's the real simple thing where you just go out and you start automating the simple stuff in order to free up resources and to free up time. So with automation, you want to start with all of those simple things. Find the real simple things that you have to automate and just automate them to free up that resource time. Also, check everything into version control. I can't say it enough. Version control, version control, version control, version control. We use GitHub Enterprise internally, and all of our code sits in there. We do pull requests in order to get it to production. But also develop a really good flow to get your code into production. So when we started with our network development journey, we put all of our code inside of GitHub and we used GitFlow. It's an industry standard practice to approve code from a user's kind of feature branch to a UAT branch called develop, and then finally into master. And then finally, don't make the same mistakes we did whenever developing software. I know that this is 3 images: build, test, release. Test, 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 test. I'm going to say it again, test. We started off, we didn't have testing available, or rather we didn't have a really good method for it, and adding it on later is really painful. Start at the beginning with testing your code. So why should you put your code inside of a Git repository? It allows for collaboration of all of your users to put code into a single place, and it creates that single source of truth where all of your code lives. So there isn't multiple different repositories of code. You don't know what version code is. It's all in one place. Git flow, I highly recommend you take a look at it. It's an industry standard practice. For those of you that are not familiar with Git flow, it's the process where your engineers check code in and go through a specific workflow to get their code into production. So with Git flow, we personally just use the standard one out there. I believe it's called just Git flow. But when our engineers check in code, they check in code to their own feature branches, and then they go through a pull request to get their code into our develop branch. That's what we consider UAT. And finally, every 2 weeks on a sprint cadence, we release code into master. And actually, over the past week, we got rid of our develop branch. So what we found as a personal learning is engineers were creating code in their feature branches, and the review process to get into develop has become so rigorous and stringent where you just couldn't get anything in there. It was the equivalent of taking code straight to production. So we have a very complex review process to get code in, so we go straight from feature into master and get rid of the 2-week cadence, and that's just the learning that we have. Event response is the second piece of our journey. So when we started off with network development, we thought, okay, we're going to bring in this thing. It's this tool called Ansible. If many of you have maybe heard of it, maybe you haven't. It's a tool that enables automation. It allows you to write playbooks and procedural files that explain how to do this automation. And we quickly found that engineers would write this automation, and then engineers would say, okay, I wrote this piece of automation that every time this happens, I have to run this piece of automation. And we see the engineers sitting there at their computer, and they get a ticket, and they go run a piece of automation. And we thought, well, that's the next piece of our journey. How about we automate that piece? We already have great eventing systems out there that collect events, alerts from the network. Let's tie it directly to our automation platform. So we went down the path of event-based automation. With event-based automation, our goal was to collect events from the network, analyze them, and make something happen. The something that we started with was just plain automation. Let's make a piece of automation start. Let's have something run against that network when an event is received. We're also looking at analytics and advanced telemetry. So the one piece that we always find out from network engineers is an event happens and I don't have enough data for that event. I don't know what happened because the information coming in isn't coming in fast enough, or there isn't enough information coming at me. Now, we can solve that problem one of two ways. We can either go to all the devices and turn on full verbosity and collect terabytes of data every minute, or we can just wait for the event to happen and then go configure the device to send us that telemetry when we need it. And that's the idea behind event-based automation. Now, let's talk about incidents. I assume everyone works with like some sort of incident pipeline, a ticketing system. Events come in, something happens, and you get a ticket cut to you. Usually you don't want those tickets to come in the middle of the night. You don't want them to have a high severity where they wake you up and you have to go and work on the network. What we introduced this concept of essentially the smart incident, where our alert collector will actually collect all of those same alerts, and originally those alerts would just go straight into our incident system. We put a fork in the middle of it, where essentially those incidents go to our automation platform. It'll look at the incident, and this is where it makes the decision. So let me give you an example of how we're doing incidents today using event-based automation. So one incident that we were receiving a lot of tickets for was wireless access points down. The access point would send an alert to us, and then we would cut a ticket to the engineer. The engineer would then have to go and diagnose. After speaking with the engineers, it seemed that the steps they were performing in order to diagnose and fix that access point was always the same. So we built a playbook for it. Now, when that wireless controller sends our alert collector the access point down notification, our system grabs that alert and it'll actually run that playbook while also creating a ticket. So the engineer will see that I have a ticket in my queue, they'll get an email, and we'll instantly start working on it. The benefit that we achieved here is access points are sometimes unpredictable, where maybe 15 minutes later that access point will come back online. So the engineer, by the time they get to the ticket, and they're getting a lot of these every month, it might be an hour, 2 hour, if it came in at 2 a.m., they're not actioning on it until 9 or 10 a.m. So they were looking at the access point, most of the time it's like, yep, this thing is fine, don't have to do anything. So we were able to action a lot faster than the engineers. And actually, in some cases, we're able to resolve the incidents for them. So the next step on our network development journey is fact collection. And this really starts contributing into the greater image of desired state configuration, the place where we all want to be with our networks. With fact collection, the idea is that network devices have the capability of streaming telemetry to you. If anyone's familiar today with SNMP, Simple Network Management Protocol, there's a lot of platforms out there that'll go out to network devices and pull down information from those network devices, query them. Essentially, I believe the best systems out there can query that data every 5 minutes. So you can see a graph and a chart of data plotted every 5 minutes. And that's as good as it gets. We've tried doing faster, it's just too much load. So network devices are receiving the capability of streaming telemetry to us every 5 seconds. So we don't actually have to go out to those network devices to pull that data. The next thing with fact collection is also how do you differentiate between data that is coming from a network device and data entered by an engineer. Today we're not at the point where we can configure a whole network without engineer input. At some point, we'd love to get to the point where we're fully integrated with every system and understand everything, but there is still a big piece of the engineer giving you information saying, yes, this is the type of network I want. Yes, the network should be blue. It should have this much capability. For like a provider, for an internet service provider, telling us how much bandwidth we have, telling us which of these cables is the primary, which is the secondary, that's still something that requires an engineer intervention. Now, the idea behind fact collection is we want to start collecting this data and doing more with it, and not just collecting it, but having it readily available and doing smarter things with it. So the first step in our fact collection journey is building a single source of truth. We, over the past few years, have gone through many iterations of having multiple sources of truth. I think if you go to any presentation talking about data, everyone will tell you build one source of truth and make sure that's one source of truth. You could copy data to a data source clone. I don't recommend it. Have one source of truth. I'm about to totally go back on my word and copy the data in a moment. However, for your automation systems, have a single source of truth where they can access that data. Now, based on the size of your network, you may want to also consider having your data go somewhere else in terms of reporting. So we have an amazing insights team that works with us for this data. When we collect this data, we do send all of the data to them for archival purposes and for reporting. So they will go ahead and build reports on this data at a later time, but we do not keep any historical data. So this makes a really good differentiation between who should use the data. If you're an automated system, if you're an API, if you're capable of taking data and making a decision right now, you take the hot path. You talk directly to our data store. If you're an engineer, if you're building a report, if you want to know historical data, you go to our insights team to build those dashboards to gain insight on the data. It creates a very clear delineation between those two professions. So here's that whole fact collection in practice. The concept is network devices will take that configuration data and stream it to us to a centralized collector. In this case, we are using Azure Cosmos DB. That data then goes to an analytics pipeline. Similar to our incident pipeline, the analytics pipeline takes that data and pushes it into that cold storage. Now, the one capability that we now have enabled here is we've enabled for advanced scenarios, such as machine learning, AI, to really look at this data and to make smart decisions based on that data. And then finally, it makes it over to that cold storage where we can go and report on it over time. So let me give you an example of why this is important. I just gave you an example earlier of an access point going down and causing an alert, and then we have a piece of automation that goes fixes it, right? Event-based automation, it's great. Now, the thing that event-based automation will not fix for you is the history piece, the time. So let me give you an example. We have an access point, and over the last 2 weeks, that access point has gone down 40 times, right? Because we have automated it, for every one of those 40 times, that access point has been remediated, brought up, rebooted, whatever the step is to bring it back online. As a human, we look at that piece of data and say, whoa, it's been down 40 times. There's obviously something wrong with this. My users that are connecting to it, they're having a horrible experience. What am I going to do about this? Well, we've automated it. So the engineers never see that ticket unless they look at their ticket history, which they already have so many tickets. They're not looking at history. They're looking at what's on their plate right now. They'll never fix that. It'll just keep rebooting, right? And with our luck, these access points are always located next to our CEOs or directors, people who really need the network that always complain that it doesn't work. Those are always their access points. I don't know how we figure that out, where we place the really bad access points there, but we're really good at it. So we're at least doing that really well. Once we introduce fact collection, once we introduce machine learning and AI into the pipeline, we're now taking those alerts and gaining more insight out of them. So yes, the incident pipeline at the top, we're getting the alert of access point down. We're fixing it. We're closing the ticket. And we're sending that data back into the system. Now, taking that data, pushing it through ML, it finds an anomaly and says, this access point has been down 40 times over the last 2 weeks, or we kind of set our own boundaries around that. And now we can create a different type of ticket that goes to the engineer that says, there's something wrong with this access point, go replace it. So now we're really looking at all the corner cases and how we can help engineers deliver a better wireless service. Finally, I'm going to end on desired state. Desired state is where we are aspiring to be. We are not at desired state yet today, but here are our thoughts around desired state in the category of networking. So with desired state configuration, in order to achieve desired state, network engineers need to create essentially blueprints of what they want, right? What we call this is the network code or the configuration. If you talk to a network engineer today and you say, hey network engineer, I want to know how a device is configured. Where do I go to find that? 99.999% of the time, the network engineer will say, you should go to the network device and run show running configuration. That's how it should be configured. So, based on what we know from Azure, if I want to know how a server is configured, where do I go? Do I go to the Azure portal, or do I go into the VM to see how it's configured? Right? Or do I go to some other system that actually says, this is the template, this is how it should be configured? We measure things like compliance today, but we don't actually do a desired state on these devices. So the idea is network engineers create a desired state. They create a configuration of this is what should be on the device, and I want you to enforce it. Now, the best example I can give you of this, and it's something that we don't do in network engineering today, is web servers. So web servers in the past, let's go back to 1995. You want to build a website, you want to host your own website. You got to go build a web server. You got to know C++. You have to know the web standards. Who today builds web servers? It's maybe 5 people. We've gone through the different steps of creating these things called abstractions. If I want to build a web server today, I think in Node.js, it's 4 lines, and it's actually the Hello World project. I don't have to know how a web server works. I don't have to know the web standards of a web server. I don't have to know all the compliance things. I don't have to worry about the vulnerabilities because someone else takes care of that. We need to bring that to network engineering, where we start taking the network features that we have and abstracting them and providing simpler services that allow other people to build on top of it to build a greater service. So, how do we get to enforcement? Right? We have these network engineers creating this thing that we call network code. And that is an abstraction of what it is they want configured on the device. All of that is stored within GitHub. We also have network engineers contributing to our fact store, this Azure Cosmos DB that we talked here at the bottom. But that fact store is not only being fed in by network engineers, it's also being fed in by the fact collection that we're doing to the devices. So now we can actually take the two pieces of network configuration, what the engineers want and what is actually out there in our fact store, combine them together to create a desired state configuration. Now, desired state configuration is great. If I have this thing, I just push it out to devices, right? But the real piece with desired state configuration, if I don't have this piece right here, it's just automation. I've automated building of the configuration. Using new tools with network engineering and protocols like netconf and restconf and API-based configuration, this network device is streaming me its configuration. Let's say every 5 seconds, every 5 minutes. I just have to close the loop where every time that configuration is streamed in, I'm doing a desired state comparison. And I find the things that have deviated, that have changed over time, and go through the loop to enforce it. So we have full closed loop desired state configuration. All right. Thank you very much for attending. I'm already 1 minute over. Feel free to stop by our booth. We have a lot of experts here from CSEO talking about how we in CSEO are transforming, doing digital transformation within IT. We have many other sessions. If you come by the booth, I could tell you about all the other things that we're talking about. And also, recently, Kurt Delbene, our Chief Digital Officer, released a paper on digital transformation. So if that's something that interests you, feel free to check it out online. Really smart guy, has a lot of really good ideas for digital transformation, how we're doing it, and how it could apply to your own business as well. And if you enjoyed this session, feel free to go online, give me some feedback. If you did enjoy the session, I'd love comments. I'd love to hear your thoughts. I will be available at the booth in about 10 minutes if you'd like to come ask questions. All right, thank you very much.